In this video, I am going to present the measurement of material density by a specific gravity bottle. First, we need to know what material density is and why we need to know material density. Many terms used in this video are clearly explained in my earlier video, and the link is given in the description box. You should also watch that video. In many food products, we need to know the porosity. For example, a slice of bread, as we could see in this slide. It is a porous structure, and porosity is an important characteristic of food materials. Porosity is important for mass and heat transfer, texture, and sensory characteristics of foods. It was clearly explained in my earlier video. Now, what is porosity? Porosity, that is volume fraction of air or void present in a material. We need to know the material density and apparent density of a food for determining its porosity, as it is defined epsilon A equal to 1 minus rho A by rho M, where rho A and rho M are the apparent and material density respectively. First, we need to know what material density is. Material density is the density excluding all pores, and it is measured when a material has been thoroughly broken into small particles enough to guarantee that no open and closed pores remain. That is rho M. It is the density based on the net volume of all solids and liquids phases, that is, without all pores. It retains solids, water, and fats or oil. How to prepare the sample? First, we need to dry bread at 80 degrees C for around 2 hours and then ground it into powder. The moisture content was measured as 5 gram per 100 gram sample, that is 5%. We use this powder sample to measure material density. We had taken a 50 ml specific gravity bottle, and the exact volume was written on the bottle as 49.8920 ml at 20 degrees C. We need an analytical balance for density measurement. First, we are measuring the mass of the empty bottle with the lid. It was 31.8662 gram. We are filling the specific gravity bottle with dried powder. We removed any attached powder on the surface of the specific gravity bottle by wiping with a tissue paper. We recorded the mass of the specific gravity bottle filled with a powder sample. It was 35.9581 gram. Mass of the powder sample was 4.0919 gram. It was subtracting 31.8662 gram from the 35.9581 gram, that is bottle mass with sample. Place a funnel on the neck of the specific gravity bottle so that it could be easily filled with hexane. Hexane was used as a displacing liquid, and its density is 0.6590 gram per centimeter cube. Toluene is commonly used for displacing liquid. However, toluene is carcinogenic, therefore it should be used in fume cupboards with care. A specific gravity bottle was then filled with hexane up to its neck. After filling, place the lid so that some hexane is spilled out and then wipe out the specific gravity bottle with tissue paper. Record the mass of the specific gravity bottle with a powder sample and hexane. Mass was recorded as 67.1490 gram. Mass of hexane was 67.1940 gram minus 31.8662 gram minus 4.0919 gram, which is equal to 31.2359 gram. Volume of hexane was 31.2359 divided by 0.6590, which is equal to 47.3989 ml. Volume of powder sample was 49.8920 ml minus 47.3989 ml, which is equal to 2.4931 ml. Material density was 4.0919 gram divided by 2.4931 ml, which is equal to 1.6413 gram per centimeter cube, which is equal to 1641.3 kilogram per meter cube. Now we could calculate the porosity from the apparent density and material density as equation is given in the earlier slides. In this measurement, it was assumed that hexane entered all pores that existed in the powder sample. It is a reasonable assumption since sample was thoroughly broken into small sizes and hexane is low density fluid. Material density as measured was at 5% moisture content. I will explain in the next video how material density at other moisture content can be predicted. Thank you for watching this video until the end. I would like to thank Ms. Aida Islam for assisting me in preparing this video.